Let's study about the frequencies transverse waves produced on a stretched string. To understand this, let's consider fixed end like a wall to which string is attached, and then this string passes over a pulley to which some weight is attached. So we can assume that this is like a case where two ends of the strings are fixed and some tension acts in the string. We need to find out what are the frequencies possible in this case. Let the length between the two ends be L. Let's start doing it. Let us assume that the distance between two ends be L. So here we'll find out what are the possible modes or frequencies of vibration. The most simplest case would be where this point is a node, this point is a node, and we have one loop between two nodes. Because the two ends are fixed, so the particle at the edges will not move, therefore the edges will contain only nodes. And we learned in theory class that between two nodes there will be an antinode. This corresponds to I. Now this corresponds to one frequency or one wavelength. Let us call that wavelength as lambda 1. What is seen here is the entire length of the string contains half of this wavelength. So if the wavelength is lambda 1 here, then the string contains half of the wavelength, because a complete wave, something of this form, it has two loops in it. That's a complete wave. From here lambda 1 is equal to 2 by L. We also know that V is equal to into lambda, implies F is equal to V by velocity is always given by V by mu, assuming that tension remains constant. Therefore what we get here is, for one loop we get one loop, then the frequency which you call as F1 is equal to V as it is, lambda 1 would be 2L. This is the first frequency called as fundamental frequency. This is the fundamental frequency, also called as first harmonic. Let's take a case where a stretched string, we have two loops. This would be a node, this would be a node as seen earlier, and center of this also would be a, we get two loops like this, loop like this, loop like this. Now this would be a node, this also would be an anti. In the length here, if the wavelength is lambda 2, the wavelength will vary because the size of the wave is varying. Now this length of the string or length of this wire contains just a wave, complete wave. So here the frequency which is F2 would be V by under 2, it will be V by L. This is called as second harmonic or first overtone. So this second harmonic or first overtone. We call that harmonics, means they are multiple of the basic waves. We'll see how to get it in a minute. And then any frequency other than the basic frequency or other than the fundamental frequency is called as overtone. We'll take a third case where we have three loops. So this would be a node, this would be a node, and somewhere here we get a node, and also somewhere we get a node. Then what we get is something of this kind. Here we get 3 loops, and let the wavelength be lambda 3. In this case, we can say the length of this string, which is L. Keep in mind that in all the cases, the length of string remains same, which is L only. This L is equal to, it contains 1.5 wave. It becomes 3 lambda 3 by 2. Therefore, from here lambda 3 is equal to 2L by, the frequency F3 would be V by lambda 3, V by lambda 3, which is equal to V by lambda 3 would be 2L by 3. This is called as third harmonic or second overtone, called as third harmonic or second overtone. If you observe the frequencies carefully, then what we get is, we get F1 is equal to V by 2L, F2 is V by F3, 3V by 2L. You can write this F2 also as 2V by 2L. So if you write the next frequency, which is called as F4, this F4 would contain 4 loops. F4 would mean fourth harmonic or third overtone. That will be 4V by 2L. So what you can see from here is, if we call this V by 2L as it is, then F2 becomes 2 times F3 becomes 3 times F1. F4 becomes 4 times F1. So in case of a string, you get all these possible frequencies. You can generalize saying that Fn would be n times V by 2L, or n by 2L V by mu, where this n called as nth harmonic. So in case of a string where both ends are fixed, we get both odd as well as even harmonic. This, the frequency is in the ratio of 1 is to 2 is to 3. Goes like this. So here we get all the possible harmonics. This is the form of modes or frequencies in case of a stretched string fixed at both the